Hello everyone, we're going to be doing lesson 19.2 in Math in Focus. You're going to need a pencil and paper, and it'd be great if you went ahead and had your textbook open to page 353. If you need to get that, go ahead and pause. If you have that, let's continue. We're going to be talking about square units today, whether they are square centimeters like the one on the page, or square inches like the one that's going to be in a couple pages in this book. So you'll notice square centimeters are much smaller than square inches. It would take more square centimeters to cover a surface than it would take square inches to cover that same surface. Very good. So if you notice, the thing about a square is that they always have the same length and width, that all sides are equal. So if it's a square centimeter, it is going to have each side would be a centimeter. If it's a square inch, each side would be an inch. As we move forward in the book, you'll notice that this unit is 2 centimeters wide and 2 centimeters down. Therefore, it is how many square centimeters. That's how we measure the area. 1, 2, 3, 4 square centimeters, or centimeters squared. If you look, 2 times 2 equals 4. So the way we find the area of a rectangle or a square is by doing length times width. We do, sorry, I need my marker here. We do length times width. So if you look, length times width. So any rectangle can be found, the area, by multiplying its length, which is maybe 1, 2, 3 long, and 1, 2 down. Any rectangle or square can be found this way. So how many wide is it? 1, 2, 3 times how long? 2 equals 6. These are in inches, so we're going to write it in inches squared. If you write centimeters, you would write it as centimeters squared. That's how the book prefers you to write it. Turning the page. So what about this one right here? Get that lined up for you. We have a figure here that is 3 centimeters across and 3 centimeters down. How many square units make up the whole thing? It says a 3 centimeter square is made up of 9 1 centimeter squares. 1, 2, 3, 4, 5, 6, 7, 8, 9. The area of the 1 centimeter square is 1 centimeters, and so the 3 centimeter square is 9 centimeters. 1, 2, 3, 4, 5, 6, 7, 8, 9 square centimeters fit inside that square. Looking forward to this one right here, you'll see that we have it 5. 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5. A 5 centimeter square is made up out of how many 1 centimeter squares? Well, 5 times 5 is 25. Very good. Of 25 1 centimeter squares. So the area of 1 centimeter is still 1 centimeter squared. So 25 centimeter squares is, so the 5 centimeter square is 25 centimeter squares. All right, moving on to just doing irregular shapes is most of what the rest of the chapter is going to show you. You'll see how many is this figure right here. Find the area. Remember, we have to be able to do these half ones. Whenever we have a half, we need to remember to add them together. For example, this one has 2 halves. 1 half plus 1 half equals 1 whole. Just like if I took this square right here and I divided it like this, it has 2 halves. Here's 1 half and here's the other half. Together it makes 1 whole, no matter how I flip it around. All right, so what is the area here? How many whole ones do we have? 1, 2, 3, 4, 5. Plus how many half ones? 1, 2. 1 half plus 1 half equals 1 whole. So that's going to be 6 centimeters squared. See how the book likes to write it like 6 centimeters squared. Down here we have A, B, C, D, E, and F. There are a few of these like this. So before we begin this, I want you to make yourself a little chart. A, B, C, D, E, F. You're going to need to write them down because the book loves to ask you to compare area of shapes in this chapter and in the previous chapters. Very good. So A, let's count the number of square units. 1, 2, 3, 4, 5, 6. 6, and it's centimeters, not inches, so we're going to write centimeters. Centimeters squared, or square centimeters. For B, 1, 2, 3, 4, and 2 halves. 1/2 plus 1/2 makes a whole. So 5 centimeters squared. For C, 1, 2 plus 2 halves makes 3. 3 centimeters squared. For D, 1, 2, 3, 4, 5 plus 2 halves makes 6. 6 centimeters squared. 1, 2, 3, 4, 5 plus these 2 little pieces here, 6. 6 centimeters squared. And this one, which looks larger than the other shapes. 1, 2, 3, 4, 5, but it has 4 halves. Let's do them together. 6, 7 total. 7 centimeters squared. All right, let's look at the questions that correspond with this. Which figure has the smallest area? Well, you can look at it and see how C is much smaller than the other shapes, but you can also look at the area. The area of C is 3 centimeters squared, so this would be the smallest. And then it asks you, which figure has the largest area? If you look at our area, F has the largest area. Let's look at the picture. Does it look like it has the largest area? Yes, it does. F is the largest. And then it asks you a fun question. Which figures have the same area? Well, notice that A, D, and C have the same area. Now, are they all exactly the same shape? A, D, and not C, E. Are they all the same looking? No, but they do have the same area. So remember that. Just they don't have to look congruent to have the same area. Let me move this up a little bit now. We're going to be talking about inches squared now, since we just practiced with centimeters squared. Just like at the beginning of the chapter, I showed you my little inch. This would be one with a half on it. I could flip it over. This is 1 square inch, so the area would be 1 square inch. This is 2 by 2, so the area would be the same as 2 times 2, or 4 square inches. This one is 3 by 3, 1, 2, 3, 1, 2, 3. So the area would be 9 square inches, or inches squared. Let's look at this big one over here. 1, 2, I'll just do it, 3, 4, 5. 5 of them could fit across, and 5 of them could fit down. So 5 times 5. What is 5 times 5? Do you remember your math fact? Good, it's 25. A 5-inch square is made up of 25 1-inch squares. The area of each 1-inch square is still just 1 inch. So the area of the 5-inch square, 5-inch going across square, is 25 square inches. Here's another non-standard shape it wants us to explore. Here we have a half one, and here we have another half one. If I put those 2 halves together, it's going to make 1 whole. 1, 2, 3, 4, 5 plus those 2 halves is going to be 6 inches squared, which we would write like this. 6 inches squared. Instead of centimeters, we're going to write inches, because remember how much the unit matters. I even sing that unit song to you all the time. Now, the book may not always make them as big as physical in inches. They may just say, hey, these are in inches. For example, down here, they look more like centimeters, right? But it writes the unit as in inches, so we are going to write our unit as inches. Let's do it. What is the area of figure A? 1, 2, 3, 4, 5, 6, 7. Let's write that down. A, well, what was that? A equals 7 inches squared. B, 1, 2, 3, 4, and then we have 5 with these 2 halves, and 6 with these 2 halves. 6 inches squared, or square inches. C, 1, 2, 3, 4, 5, 6. 6 inches squared. Now let's look at those questions. Which figure has the smallest area? Figure A or figure B? B. Very good. Then it says, you want two figures to have the same, which two figures have the same area? B and C. Then it says, you want A and B to have the same area. How would I make A and B the same? Just with numbers. Well, I could either add 1 to 6, or I could subtract 1 from 7. So you would do that on your picture. You could either take away a square from A, or add a square, or add a square to B. Very good. All right, moving on down here. For numbers 1 and 2, what is the area? 1, 2, 3, 4. What is the unit before we write it down? You'll see it is centimeters. 1, 2, 3, 4 centimeters squared. Over here, 1, 2, 3, 4, 5, 6 centimeters squared. So it says, which has the larger area? Is it 1 or 2? 2. And then it says, you want them to have the same area. Explain 2 ways of doing this. Again, I could add 2 squares. Oops, didn't mean to actually write in my book. Oh well. To number 1, or I could subtract 2 squares from number 2. Oop, we're going to do one where you guys practice. I would like you to get your piece of paper or your whiteboard or whatever you have and write down A, B, C, E like me, A, B, C, D, E. And I want you to look at the units. What is the unit up here? Right, it's inches. We're going to write that on top so we remember that it is inches, not centimeters. So we're going to write it in inches squared for area. Go ahead and pause it and try to find the area of A through E and then resume. Welcome back then. A, 1, 2, 3, 4, 5, 6, 7 inches squared. 1, 2, 3, 4, 5, 6 inches squared. C, 1, 2, 3, 4 inches squared. D, 1, 2, 3, 4, 5, 6 inches squared. 1, 2, 3, 4, 5, 6, 7, 8, 9 inches squared. Now we can answer the questions using our data. Which figure has the smallest area? Well, just by looking at it, can you see which one is the smallest? C. Do the numbers match? Yes, C, 4 inches squared. You can actually fit C, which is pretty close to this, inside each of these other shapes. Which one has the largest area? You can look at it and see E is much bigger. Look at the math. Is E bigger? Yes, it is. I could physically fit each of these inside. They made it in such a way where I could put each of these inside of F, which is kind of cool. Which two figures have the same area? B and C. Even though B and C do not look very much the same, they have the same area. That'll be it for today in the book. Let me transition over to me. Do your workbook pages that go along with this lesson. You can comment any questions you have below the video. I've had a lot of fun. I look forward to learning some more.